Hello, my name is Anthony Novokshanov, and I did my research over using explainable AI for disease diagnosis. Specifically, I'm using it for pneumonia diagnosis. My mentor was Dr. Vidya G, who helped me greatly, and I'm zooming in from Atlanta, Georgia. Oh, so why did I choose this topic? Well, AI is really big right now. Elon Musk is using it in self-driving cars, ChatGPT is just taking control of everybody's lives, but we still haven't seen really a large use of AI in hospitals. Why is that? Well, hospitals just can't trust the output of an AI. The doctors and nurses, they don't understand how the AI got its answer. They don't understand the biases that are associated with it. They don't understand the exact features that were being looked at when the patient was classified. So for this reason, explainable AI is becoming very, very important. Uh, Explainable AI is able to open a door so that researchers and scientists and doctors can see exactly how the AI got its answer, see exactly what features made the AI think that somebody has a disease or doesn't have a disease. When people's lives are on the line, stuff is very important. So before I start talking about my project, we have to just talk about how do you actually locate pneumonia? Well, pneumonia is generally just a lot of white cloudiness in the lungs. You can see over here, there's these white splotches, and that's just where the pneumonia has, infested the lungs. So the data set I was working with was the pneumonia MNIST data set. It's a sample of 6,000 images, grayscaled images of 28 by 28 pixel density. So they're a bit blurry, but you could still see, all the important features. Uh, the first step of, making this explainable AI was developing the deep learning model that I would actually use to see if lungs had pneumonia or didn't have pneumonia. So for this, I chose to use a convolutional neural network. This is pretty much the industry standard for anything you're using for vision or image analysis. It's used in facial recognition, advertising, autonomous vehicles, and I was able to train my convolutional neural network to have a 90% classification accuracy. So how does my AI actually detect important pixels, or how will it explain how it got its answers? Well, the output of my convolutional neural network is a vector, right? A true percentage and a false percentage. So in this case, the AI thinks 80% certainty that this set of lungs has pneumonia, and a 20% certainty that these lungs do not have pneumonia. And then what I would do from that point is use data augmentation to create a large data set of images, very similar to the original image, except with slight augmentations. In this case, replacing a single pixel in each image with a black pixel. And then I would run this new image or this new set of images through my AI and see how this classification vector changed. Maybe I put a black pixel in the middle of my picture of lungs, and this changed to 0.6 and 0.4. So I know oh, well, that pixel was very important. Uh, so researchers should be looking at this pixel because it changed its prediction from 80% true to only 60% true. So what does this actually look like? So if this is my original image and I run it through my classifier and I create this new set, this new 28 by 28 set of images with each pixel blacked out, and I graph the magnitude of the change, it would look something like this. So when this image was, so if this pixel was blacked out, that would correspond to this magnitude of change. So as you can see, the lighter pixels in the center of the lungs were generally had a higher magnitude of effect on the prediction of the AI. The bright yellow hotspots are especially necessary places for doctors to check for pneumonia because they had the highest magnitude of change. So in this pixel, this corresponding pixel was changed to be black. The AI really thought, oh, that was super important. So it changed its prediction drastically, or more drastically, at least than the rest of the pixels. There's just more images of this in progress. And then I would show this on the original image. So using the same images, right? So this is my original image, and this is the, magnitude image. I can then display the top, X amount of pixels on top of my original image. So researchers would know, oh, this is an important spot over here, or over here, or over here. So there's just a collage, multiple different images showing the top. I think this is top 100 pixels. So in conclusion, I was able to develop a image classifier as well as an explainable tool that is on top of this image classifier. In the future, I would like to test this data set on, or test this example, AI on a data set with higher pixel density, so we can really see the more like nuanced pieces of the lungs. And then I would like to ask healthcare professionals and how they think this could help. And I would also augment my algorithm to, instead of going pixel by pixel, to break it down into a group of pixels and then smaller and smaller and smaller, so it's maybe more efficient at classifying. Hope you guys have a good day. Thank you.